Any questions?
I actually do have a question, but it's something from one of your old tests.
Yeah.
It's the long answer question from, it's 2021, chapter 1A. And it has to do with the hockey puck.
Okay.
And I think the thing that I'm most confused about is the acceleration. Like, where is it at 0? That's the part that is tripping me up the most.
All right, I'm gonna talk generically and then we can do specifics.
Okay.
All right, so hockey puck, is it going down a ramp at all, or is it just going to the left, that hits
Yeah.
something?
Yeah, so a hockey stick hits the puck and then it hits a box at time C.
All right, so there's the stick hitting it,
Mm-hmm.
and then there's the
The box.
box.
Yeah. And
There was a
then
friction area also, wasn't there?
Yes, and then there's a wall too.
Good wall,
And yes, there was friction.
and somewhere in between.
Yes, there's friction. Like once it's like making its trip back.
Okay, the
There's
friction
like a-
mysteriously appears.
Huh?
The friction mysteriously appears?
Yeah, at some point.
Okay, or magically.
Yeah, it's saying between K and L is where it has friction.
All right, so on the way back, there's friction.
Yeah.
All right, so at this point, we've talked about forces. So let's just think about force diagram. When the stick hits it, stick's hitting it that way, what are the forces acting on it? This is open to anybody. What's the force?
Gravity force, gravitation.
Okay. Or weight. All right, so got weight pulling down on it.
Given other force with the stick.
Okay. In this case, you could consider it another, or it is a normal force. Any green? What's the third one? Anyone else? This would be really impressive if you just randomly threw out a word and it turned out to be right. I'm hearing sounds, so maybe it's just rustling. Maybe it's the voices in my head.
What is the,
It's a puck, and it's being sent to the wall.
Would it be tension?
You got a
Like
road
if it's
for it.
hitting, the stick is.
If it's tension is a pulling force,
Oh,
normal is a
okay.
pushing force, so it's this is from the stick.
Oh, okay, never mind.
oh, the other normal force of the box, no?
We're not there yet. We're just looking at the stick.
Okay.
Will you have friction from the stick and the puck, or is that?
I'm assuming there's no friction between the stick and the puck. I guess in reality, the stick is going to slide, but we're pretending not. All right, if these are the only two forces acting on it, that means that puck is accelerating in that direction.
Friction force.
Between what and what?
We just naturally just are up here.
The friction's not at this point.
The friction is like this one you hit.
It's after it hits the wall on the way back somewhere in here.
Normal force, so
Yeah.
it doesn't go to the ground.
There's a normal force acting up, well, since there are different normal forces. Yeah, something's holding it up. It's not digging into the ice. All right, so if I get these three forces, the weight and the normal force from the ground are gonna cancel each other out, neutralize each other. What's the direction of the total force acting on the puck? So what's the direction of the acceleration? So I think to the right was positive. So positive acceleration to start with. It hits the box. When it hits the box, what are the forces acting on the puck? Going which way?
Oh, it's going up.
All right, so the ground's holding it up also.
Do we assume the box like slides with it, or is
No,
it?
it's gonna
No,
crash
it
into
goes
the box.
through, like, the box disappears apparently once the puck goes through.
It hits the box and the box is shattered
Okay.
and then the pieces disappear.
So
Like a
it's-
vampire being slayed.
So it's still going to the right, so there would be a normal force going to the right?
Oh, from the stick?
Yeah, but still going that direction.
No Jedi powers. Normal forces cannot exist at a distance.
So you're hitting a hockey puck at a box with a stick standing.
There's a puck on the ice, you hit it with a stick. Stick hits it, it goes through, the puck hits the box, it's gonna hit the wall, on the way back, it's gonna hit a friction area. And then, I can't remember if it stops or not, but
Yeah.
it does stop.
Will there be a normal force going that way, cause the box?
Yes, when it hits the box is pushing on it, so there's a normal force going this way from the box. This is, I guess. So, looking at the total forces, what's the net direction of the net force? So the acceleration is, yep. And for those who missed it, they were pointing that way. Now it's gonna hit the wall. While it's touching the wall, what are the forces acting on it?
Gravity.
Allie, what did you mean you say?
Gravitation. Wait. I've rubbed off on it.
Or gravitational force, or force due to gravity. Alright, and,
Normal force going back that way.
alright, so I got the normal force from the wall.
Why is the normal force from the wall on the left?
Why is it going that way?
Yeah.
Which way do you think it should go?
I assumed it would be up and down, no?
Oh, there's a normal force up, also from the ground.
And then the normal force from that is from the box hitting it?
But where are you? Here?
Yeah.
That's from the wall,
What wall?
this wall. The puck hits a wall and it's gonna bounce back.
Right, okay.
There's a demonstration. Except the puck bounces back in a more ideal way.
But when it contacts,
Right?
that contact will mean that there's normal force that way and that way.
Acting on two different objects.
Two different objects.
Yeah, so this is the force that the wall exerts on the puck, and then there's gonna be a force that way on the wall.
Oh, okay.
So just then, the wall pushed on the marker this way, and the marker pushed on the wall that way. But we're
Okay.
concerned with the puck itself. All right, so, direction of the net force, direction of the acceleration, same way. Comes back, hits the friction area. So what are the forces acting on it now?
Wait.
All right, I heard weight, and I'll go ahead and spoil it, normal force acting up. Which way is friction acting on it? So, which way is the net force? And which way is the acceleration?
The right.
All right, so now in terms of, so my acceleration is right. So if that's positive, my acceleration bigger than zero, acceleration less than zero, acceleration less than zero, acceleration greater than zero. We can look at it in a different point of view. Okay, first off, any questions to this before we look at it from a different point of view?
Okay, so the objective here was to figure out where acceleration would be greater than zero and where it would be less than zero,
Or equal to zero.
or equal to zero.
This was the long problem from 2021?
Yes.
taking a look from a different point of view. So we have the puck here, and I'm gonna make it lower to the ground. We have a box here, and then we're gonna have a friction area that magically appears on the way back. So it starts at rest, I believe. It then picks up speed, so I don't know what the new velocity is, but if that way is positive, then I'm just gonna say it's going 20 meters per second. And meters per second, and this way I can not bother writing units. When it hits the box, it's going 20. There's nothing to slow it down in between. It hits the box, it's gonna slow down. I don't know what it's gonna slow down to, but I know it's gonna slow down. There's nothing to slow it down until it gets to the wall. And then it turns it around, so it gets to 0 at some point. If it turns around, I have to go through 0 in a one-dimensional problem. And so now it's shooting back. The box isn't there anymore on the way back, but the friction is, so it's still going -15 on the way back here, and then it comes to a stop. Does this seem like a realistic representation of the problem?
Yes.
So if we look at the change in velocity, because if you think about the linear motion lab, where in general, what is the sign, when is acceleration positive? Acceleration is positive when the change in velocity is positive. It's 0 when the change in velocity is 0. It's negative when the change in velocity is negative. Well, let's look at each segment here. What's the change in velocity here?
10 meters per second.
How'd you get 10?
Or, sorry, I was doing the average.
Yeah, looking for
Yeah.
change. We'll start again. It goes from 0 to 20. What's the change?
20.
Just
Sorry.
positive 20.
Sorry.
It's final minus initial. Then from, so that's in this region. From here to here, what's the change?
Nothing. 0.
From here to here,
-5.
from here to here,
That's 15, right?
yeah, 15 and
Okay,
15.
0.
From here to here,
-15.
from here to here,
It's -15.
it's still -15. It's -15 minus 0. From here to here, and from there to there. That's positive 50, yeah. So my acceleration is positive, 0, negative, 0, negative, negative, 0, positive. A different way of looking at the same thing. Questions on this before we look at it another way?
For a problem like this, would we just to be given numbers to solve for all that, or just the diagram?
You're given the diagram, the points in time, and then the chart.
Just to figure out what it does in a certain amount of time.
When it's at plus, minus, or 0.
Okay.
I give I give 4 different formats for the presentation of the answer. Pick one. Don't pick all 4. But if you're gonna pick more than one, please make sure your answers match each other. The number of times I've seen people pick more than one, do all 4 actually, and they have different answers in each one.
Well, what did you do there?
I don't know if I have a set way of dealing with that.
Like, if you
I
were-
sometimes average all 4 of them, sometimes I take the lowest of the 4. It just depends on my mood at that moment.
If you just laugh and see like 7 different ways it's been solved and 7 different answers.
Flashing back to the student who wrote an encyclopedia, 4 different ways in the same paragraph. Be consistent, whatever you're gonna do. All right. The other way of looking at this is the velocity is positive in this direction, from here to here. So the velocity is greater than 0. Going that way, velocity is negative. So if it's speeding up, acceleration will be the same sign. Well, it speeds up here, so acceleration is positive. It slows down here, so acceleration would be negative. And it slows down here, so acceleration is negative. So while it's going this way, whenever it slows down, acceleration is negative, speeding up is positive. Going back the other direction, if I go from 0 to negative 15, well, I'm speeding up. By the way, despite what some students might claim, you cannot slow down if you're at rest. So it goes from 0 to negative 15. I'm speeding up, my velocity is negative, so acceleration is negative. Here, I slow down, so my signs will be opposite, so acceleration is positive. All three ways should come up with the exact same answer, so this should not matter which way you look at it. The forces one is always going to work, assuming that you get the forces right. So, oh, there it is. Was that
So, yeah, looking at it like a different way makes better sense.
okay? Which way worked best for you?
So I actually did the plus and minus, like I would put out all the letters.
Okay.
And did like the chart like that. That's the way that I've been doing it.
Okay.
When I practice them.
Other questions?
How many questions on the test? It's just.
I hit a randomization program and it just randomly throws problems in it, anywhere from 1 to 100. How about that? Oh, that'd be kind of cool if I actually did that. Scary, cool, I don't know.
We'd be here till night.
If your entire test grade depended on one question, would that be too much stress? Right now it's too long. Okay. In the absence of other questions?